Hey, what's up guys? Thanks for joining me for another video. You guys asked for it. Here it is, full build video. This is gonna be a two-part video. Part one is gonna be us here in the shop building this thing from start to finish. Part two is gonna be us getting out and shooting this thing and seeing what it can do. I am stoked. You're gonna wanna see part two of this video, trust me. Subscribe if you want, hit that little notification bell at the bottom, go to griswoldgunsmithing.com, get your gear. I'm stoked, let's just get right into it.
I'm Trent Griswold. My shooting career started at a young age thanks to my dad, who's a Marine and 40-year law enforcement veteran. I've done just about everything in the shooting industry. Competition, instruction, consulting, you name it. It's been a wild ride. In 2009, I graduated with my degrees in gunsmithing and opened up shop to build long-range precision rifles with my brother. Come on in and take a look at some of our latest projects and adventures. All right, ladies and gentlemen, here we go. We got our build laid out. Let's really quickly go over the components and show you what we're using. We'll start with the meat and potatoes here. This is Terminus Zeus Action, integrated rail, 20 MOA, integrated recoil lug, 3 lug. So that'll give us a nice short bolt throw. Here's the bolt, one piece, absolutely beautiful. Trigger, we're gonna be using a Trigger Tech 2-stage trigger for this particular build. Barrel selection, we're gonna go with a 26-inch 1 1/8 twist proof research carbon fiber barrel. I am gonna run suppressed most of the time, but I wanted something to put on there when I wasn't, and I chose the Area 419 Sidewinder, which I've not used, so we'll give that a try. Moving along to the chassis, this is an MDT ACC Chassis. Out of the box, I've not used one. It looks absolutely gorgeous. I've heard great things. I can't wait to get my hands on it and use it myself. This is one piece of aluminum from here forward. Very cool. A lot of adjustability and modularity. All right, so there it is. That's the layout. I'm not gonna hold you guys up any longer. Let's get right into this thing. Okie dokie. So we've stripped our action. We've cleaned it really well. Make sure there's no debris in there. We've also removed our fire control and our ejector. We can keep our extractor in there. We wanna make sure that nothing gives us a false reading along the way when we take all of our measurements. We've looked at our barrel. We've looked at it with a bore scope to make sure that the bore is good and this is a good barrel. It passes our quality control before we even start. Normally, I can start fitting our piloted bushings here at this point. On most other barrel manufacturers, I can get a bushing in there and feel for what's going on. I can get the right bushing right away. However, for whatever reason, I think maybe because they put this thing on center, on a barrel spinner in order to get the finish here, but the first portion of the rifling is kind of peened over and damaged a little bit, which is totally fine. We have to cut this off anyway. So we got to do that before we fit our bushing in order to get this thing dialed in on our lathe. So let's get this thing over to the bandsaw and get that going. I had something weird just happen just now. A part to my vise broke and I can't tighten my vise, so I've got a C-clamp here, which is less than ideal, but we'll make it work. I'll have to figure out what's going on there and fix it. Anyway, we're all ready to cut. We got some aluminum in there protecting our barrel against the vise jaws, and we are about ready to get this thing cut. I'm gonna have to kind of hold this as we go, so might not be the best video, but here we go. There she is. Okay, got her lopped off. Let's get it cleaned up Let's see what we got. Aha, we forgot a step. We have to add our biscuit to the pile. A lot of people ask how many barrels we've done in this shop. About that many, plus probably 50 to 100 that we didn't keep before that. Barrels in there, 3-jaw, torqued down. Come around over to this end, we've got the 4-jaw spider, and I didn't really dial it in over here. Literally just kind of eyeballed it. This is just to kind of support it. And we're just gonna face this thing off. You'll see how rough this cut is with the bandsaw. So we're gonna face this off and get a clean surface to work with here. Got a little lapping compound here and a brass lap. Just use what's on the lid. And we've got it faced off. We've got it cleaned up. Now we can find the right size bushing for this bore. This is one that was just on there from the previous build, just over 30 cal. These come in very, very, very fine increments, and they go up in steps, so we find the right one that'll fit this bore perfectly. I'm just gonna see where we're at with this one. Yeah, it does go in. A little bit of chatter as I move it in and out, so it's a little on the loose side. We want a nice snug fit, not tight, but snug. We want full contact on all lands as we go around. So I'm going to sort through my pile here and find one that fits just perfectly, and that'll help us get dialed in. All right, we found our bushing. It fits perfectly. It's 0.3002, and we put it in here, and it wants to go in nice and snug. It's got full contact, no slop, beautifully all the way in. So this is going to be the bushing that we use to dial this thing in on the lathe. We've got our barrel in there. We've got our 4-jaw on this end, and we've got our spider on this end. Now here's what we're going for. We've got our range rod in there, and right now my bushing is on the very breech end here. We're going to run that fore and aft and take different readings and get this thing dialed in right now. So I've not started dialing this in yet. It's in there very rough. All I did was bring my center up, my live center that was here just a minute ago, and got close, a reference. Now you'll see how far off this end. We got 15 thousandths of movement. Completely unacceptable. We're gonna dial this thing in extremely, extremely accurately. So this is what we're going for here. No bore is perfectly straight. They all have a curvature to them. It's virtually impossible to drill a straight hole the way that these barrels are manufactured. The most critical part for the breech end when the chamber goes in, or sorry, when the reamer goes in to cut the chamber, is that the very first portion of that, where the pilot is, that's going to be where the bullet touches the lands and grooves first. We want to make sure that the bullet, when it leaves the case and it engages the lands, that it engages all of them perfectly evenly. So really all we care about, not all we care about, but the most important part is that we're dialed in perfectly at that point. So it gets a fair and even engagement on those lands. And the way we do that is we're going to go back and forth. We're going to measure out here, and actually this measurement right here is going to be determined by what I do on that end. And then as I run this in, this measurement, you can see that's even a little bit better already, is going to be determined what I do here on this 4-jaw. And so we're going to chase our tail back and forth until we get both to align as best we can, but again, paying most attention to where that bushing is and the beginning of our reamer, or I guess the finishing point of our reamer, the chamber portion. Hope that makes sense. This is going to take some time. Sometimes it takes minutes. Sometimes it can take up to an hour to get this thing dialed in perfectly. I'm going to, this is just measured in thousandths. Once I get that dialed in, we'll use one of these other guys here, and you can see we're at 0.0001. So this guy's extremely sensitive, and that's what we're going to use to make the final dial here in on our barrel. We'll check back in when we get this thing a little bit closer. It took some time, but we got her dialed in perfectly there. Back out. Our bushing's just at the end. No movement on the needle there. We are dialed in, ready for the next step. I wanted to take just a second to kind of further explain the concept and theory of dialing the barrel in on the lathe. I mentioned that none of the bores are straight, that they have a curve or an arc to them. So I've got this piece of welding rod and bent it in a curve to kind of exaggerate what's going on there, but nonetheless, they're all curved like this. So we want to pay attention to dialing this in on this side right here. This is what we're trying to get true. We want this first section of the barrel to be straight. We don't care about this. A lot of techniques in the past, people will dial in both ends and then they'll get this in the middle. Now, if we were to do that and our reamer comes in and it's not in line with bore, what's going to happen is when the bullet leaves the case and start to engage the lands and grooves, it's not going to do it evenly and it causes disruption. Okay, so all we care about is that very first section. We want to get that lined up. That's what we were doing with our range rod, and so that we can start and come in here perfectly in line with bore, and that we get equal engagement with our lands and grooves. Now when we're done with that, we're going to go to the other side, we're going to flip it, and we're going to do the crown and the muzzle end. And we want the same concept to play out there, right? So when the bullet leaves, if it's like this, and we cut it off in here and we crown it, and the bullet leaves like so, you're going to have gases escaping on one side quicker than the other. You're going to get a low or high pressure on one side or the other. It's going to cause the bullet to yaw. So anyway, I hope that explains a little bit about what we're trying to do as far as dialing the barrel here. Now here's something else. We can actually use this curve to our advantage. What we're going to do before we cut our chamber, we're going to index the barrel to where the curve of the barrel is going in this position. It's giving us, you know, essentially a little bit more elevation, or at least less bullet drop. So we can use that to our advantage. What we don't want is it to be over here and give us a poor windage adjustment. Even down would be better than a windage adjustment because we could just dial for elevation. But we're going to give this a little bit extra elevation by indexing our barrel properly and giving us a little more elevation. Hope that helps. Let's get back to it. To demonstrate that curvature of the bore I was talking about and what we're dialing in here, I'm going to fire the lathe up and you'll see how concentric and axial we are here and how out the muzzle end is. So here we go. Check this out. It's beautiful. Everything's true, right? We ran our gauge in and out. Look at the wobble on this. So there's that curvature that we talked about. So we'll take a measurement here before we start cutting our chamber to find out what our high spot is and give us that extra elevation that we're looking for. Now we're getting ready to start laying things out and start cutting here, but before we do that, normally what we would do is we'd go to our action and take all of our depth measurements, because essentially what we're doing is we're fitting the barrel to the action and the bolt. Now, what's nice about these Terminus Actions is that he's basically already done all this homework for us. Normally, I would make a blueprint for the particular barrel that I'm going to cut, and I'd get all my measurements set so I can just refer to that and cut everything over here at the lathe. However, you just jump on their website and he's already got the full thread tenon blueprint right here. Now I double checked the action anyway. Of course, we're not just going to rely on this information. There's a variance in manufacturing, but from what I gather, it is dead nuts on. I measured 0.0735 depth from the recoil lug face to the bolt nose, and I'm assuming that's exactly what he was going for because that's 10 thousandths deeper than 0.725. Oops, sorry. Let's do that. 0.735. So I'm guessing that's exactly what he was going for. I usually like to go for about 8 thousandths on a tactical rifle, 8 to 10. If it's bench rest, we'll tighten things up a little bit, but we need to allow for debris and temperature change and things of that nature. So he made this really easy on us. I'm gonna basically go off of this blueprint here, and we're gonna cut this tenon and get this thing chambered up. So I appreciate that. Thanks, Terminus. I'm already becoming a fan of your action. There's also another step that we don't have to do on this barrel, which is kind of nice. Because of the way that the bolt nose is shaped, we don't need to do a relief cut for that. Normally we would do like this. We would have a relief cut for the bolt nose on a safety breech or Remington 700 style rifle. But on this, we're just going to be doing a flat breech essentially. So that's one less step we have to do, and it'll speed things up a little bit. So we've got a measurement of 0.725. Got that dialed in on our kind of junky set of calipers here. So let's start laying this out. Let that dry for just a second. And now we can make our mark. We've got our line. So there's our 725. It's okay if we overshoot it a little bit because we can always come in here and shorten it by just facing this off. So we're gonna get our threads cut and we're gonna index it like we talked about, get all that set up. And at that point, we can do our chamber. But first things first, let's get this tenon cut, let's get some threads cut, and go from there. Okay, we've got our left hand cutting bit in there, ready to go, ready to start carving away at this tenon. Our diameter, obviously we need to know what we're shooting for here. So again, he's already got this homework done for us. 1.062. That's our max. We have a negative tolerance of 0.0005, so we can go 1.0625 if we want. We'll shoot for that 1.062. And so that's our depth. Our diameter. We got to make sure we do not pass that. Here we go. Let's start carving away. I like to do 20 thousandths passes, nice light passes. We're going to scratch away at this. We don't want to disrupt our beautiful job of dialing this thing in. Here we go. Set up for threading, ready to go. We've got some dicum down on our tenon for reference when we know when that dicum starts to disappear and almost go away completely that we're close. We've got our 60-degree threading bit all set up. We've got our compound set up. If you want to see how I set up the lathe, you can go see the last video I did, the chop, cut, thread, and crown video, and I go through how I set the lathe up for that. We're basically going to use almost the exact same process. Before we get started, let's go back over here to our blueprint, double check we are at 16 TPI, so the lathe is set up for 16 threads per inch. We're gonna do a scratch pass right now and double check that before we actually cut. I've got everything all set. Let's throw it into gear and see what happens. Fingers crossed, right? Okay, let's grab our gauge and looks like 16 to me. All right, we are good to go. So we're gonna back off, disengage, go to high reverse, back to low, 0, come in about 5 thousandths on this big first passes. We're gonna lube it up, cut some threads, and I will check back in with you in a little bit when we get closer to these threads being done. We've got our threads cut. Threads turned out absolutely beautifully. We threaded our action on there. There's nice, good snug fit. Next step, we're gonna cut that relief cut. Some actions have a gracious relief cut up here. This one doesn't. He runs his threads pretty much all the way up to the lug, which is totally fine. So we're gonna do a little bit of a relief cut here on the barrel, and we've got our homemade cutoff tool essentially. We've cammed it in just a bit so we don't mess up our shoulder. Not too worried about that yet because we're gonna still have to go back and index and clean that up anyway. But here we go, we're gonna set this relief cut here. Feeling my tool stop on the shoulder, and I'm going to start heading in. Cutting away. I've got a dial indicator set up here, and we're gonna basically just be going off the outside of the barrel. Now, I know this isn't an ultra precise way. It's not the same as if we were gonna run a range rod in there and go off a bore, but I'm gonna assume that the way these barrels are manufactured, they're either finished on a mandrel or on center. That's gonna be relatively close to bore as far as concentric. So this is gonna be plenty good enough for us to get an idea of where our high point is. You run this back and forth. We got a heck of a lot of run out, and it looks like our high point's right there, 63. Right there, right there. So that is our high point. Just a couple more times just to be sure. Right there. All right, so that's our high point. Now, basically all we're gonna do is we're gonna come back here, and we're just gonna come to the 12 o'clock position and make a mark. There's where we want the top of our barrel to index, right there. Simple enough. So we're gonna thread our action on there, see how close we are. If we need to move in to index that thing further, we're just gonna get a bit and we're gonna chip away at the shoulder. Once we've done that, we're going to measure our length of our tenon to make sure that we're not over or under. All right, so we made our mark here, and I screwed our action on, and it stops just short of that mark. A lot of people would leave it right there, but I am gonna go in and I'm gonna take just a kiss off that shoulder, a couple thousandths, and bring that a little bit closer to the 12 o'clock position. I know we gotta allow for some crush, but not much. With the tolerances that we're working with, this thing's not gonna crush hardly any at all. So, I'm gonna go in there with that bit, clean that up just a kiss, and get this thing to fit perfectly. Oh yeah, a couple degrees that will torque into position. So, okay, we've got our depth micrometer here, and it is giving us a reading of 0.730. So we are 5 thousandths over recommended length here. That's only going to give us 5 thousandths clearance between bolt nose and the end of the tenon. So let's bring it back to exactly that. This is a tactical rifle essentially. So we want to allow for some of that debris, heat, things of that nature. So we're gonna err on that at least 10 thousandths, 8 to 10. So let's shave 5 thousandths off the face of that thing, and we'll be good to go. Right on the money. Perfect. Okay. We are now ready to start our chambering process. Even though we took our measurements already, quick way you can check is screw that sucker on nice and tight. Get the bolt in there. Of course, like I said, we took fire control, all that stuff out so we don't get a false reading. And we should have that slop. Should have that slop there. At least 10 thousandths. The time has come. We are set up to do our chamber. Let's talk a little bit about the setup that we got here so far. We have a PTG floating Reamer holder here. So what this allows this to do is float around so that it works off of the pilot. We've got a pilot here on the end of our Reamer, much like the one that we use to do our indicating. So that's a very snug fit. That's what this whole system's going to work off of, is that pilot. And like I said, it's going to allow that to kind of float around and do what it needs to do. A lot of guys will pre-drill. They'll drill out most of this material so they don't have to put too much wear and tear on their Reamer. I use a roughing Reamer and then I use a finishing Reamer. So I'm not going to pre-drill. I'm just going to go straight to my roughing Reamer and rough out about 80% of it and do the last 20% or so with the finishing Reamer. And this particular process is a little bit arduous. It's kind of the old school technique, and I like it. It's kind of fun. It takes a long time, but it's a little more gratifying. We do have a high pressure flow system, and it's really fast, and it makes an absolute mirror polish on the chamber. I actually have to go back in after that process and rough up the chamber because it's too smooth. It's like glass. I'm going to do another video on that whole system eventually, but like I said, we're going to kind of do this old school way. We're going to run this in and out a bajillion times, clearing the chips, and we'll do that for a little bit, and then we'll check back in. I'll show you when we get close. We can start checking headspace and then sneak up on the headspace that we're looking for. Here we go on our first run. Everything's dry right now. We're not going too deep just yet. Some oil in there. We're going to be cleaning the bore a lot too. We clean the bore a ton. We don't want any chips to influence what's going on with this pilot, but oil everything down. Fire this bad boy up. Okay, and there's our pilot. Our pilot is now contacting the lands. It's the one driving. This is basically float around if it needs to, but that's it. lock her down, and we're just gonna creep in nice and slow. This is our cutting surface here. It hasn't even started touching yet. We've got most of our chamber cut, and now we're gonna switch over to our finishing reamer. And we set this up a little bit differently in that we have a collar with a stop on it, so we can get close to our headspace. We'll take some measurements when we start to get close, and then we can actually make some very fine adjustments with this and bump up to it so that we don't overshoot headspace. If we overshoot headspace, then what we have to do is we have to do a full barrel setback. We basically have to go in one full revolution on the threads, meaning we have to basically bring that shoulder forward. Then we have to adjust our tenon length again, and then try to accomplish getting our headspace again. We do not want to do that. The difference between a go and no-go gauge, which is what we're going to use to achieve headspace on this build, is 4 thousandths. So it's going to close on the go, and it's obviously not going to close on the no-go. And that difference is 4 thousandths. Now, to give you an idea of how tight that is tolerance-wise, I'm going to measure one single arm hair here. 2.5 thousandths. So one of my arm hairs is 2.5 thousandths. So less than 2 arm hairs is what we're going for here, and that's the kind of precision that we're working with. Sometimes we will use gauges that are in 1,000th increments if we want a very precise headspace, something that we've determined previously that we need. But in this case, we're going to, I like to go with some resistance on the go gauge. And so we're on a little bit, kind of on the tight side of things. And I think that'll work great for this particular build. So here we go. Let's finish off this chamber and sneak up on our headspace. We'll take some measurements here in just a little bit. Okay, so we're getting pretty close here. We're sneaking up on our headspace. One thing I haven't really been showing you guys is how often I'm cleaning. Every time I pull that reamer out, I'm cleaning the chamber, I'm cleaning the bore. Remember how tight our pilot is here, our bushing. So we've got to make sure that that's nice and clean. Also, we don't want to be galling up those lands with chips and stuff like that. We cleaned everything up really well. We've got our action screwed on here. We have to make sure that the chamber is spotless. You saw the diameter of one of my hairs. You can imagine the diameter of one of these chips, and that could totally give us a false reading if there's a chip on the front of this shoulder, on this gauge. The gauge has to be clean, chamber has to be clean, the lugs have to be clean, everything has to be spotless in order to get an accurate reading. So let's see where we're at. This is the go gauge. This is why I leave the extractor in. Take the ejector out, but leave the extractor in. Okay, so we're not even close here. I mean, we're close, but we're not too close. So here's how we can tell how much further we need to go. I'm going to break this loose, and I'm putting slight tension on, let me get this out of the way. I'm putting slight tension on the bolt handle as I'm unscrewing the action. And it's about ready to drop. And the bolt handle just dropped right there. So the bolt handle dropped. Now I'm just going to very gently, till I feel resistance on that gauge, tighten the action. Okay? Now we have a gap between the shoulder on the barrel and the face of the action. I can measure that, maybe. I am at, so we got 0.11 to go until we achieve closing on that go gauge. That's a very rough measurement. We have feeler gauges if we want to. Once we get a little closer, I'm going to take another measurement or two, and we're going to use our reamer stop here, and we're going to bump up on that headspace. So again, we'll check back in here in a little bit. Just wanted to kind of show you the process of measuring when we get close and how we determine how much further we have to go. Action is screwed on nice and tight. Everything's clean. Go gauge is in there. And you can see the handle just starts to fall, so we are darn close, darn close. So we're gonna back this off. Back this off till our handle drops. Boom, handle drops. Tighten until we just start to feel some resistance there. Now we can grab our feeler gauges and start at 10 thou. 10 thousandths does not fit. Let's go to 9. 9 thousandths does not fit. 8 just gets in there. So we have 8 thousandths headspace, or we're over by 8 thousandths. So I have my trusty, make sure I'm going the right direction here, Reamer stop. I'm gonna go, because we're so close, I'm gonna go 5, and actually I'm gonna go 6, and then we're gonna check it. There's 6 thousandths. Bump it. Like I said, guys, we can't put this metal back. I don't feel like doing a barrel setback on this thing, so we're just gonna sneak up on it. No problem doing that at all. So let's slowly creep up on this thing. So another technique I probably didn't show you in the beginning is that every time I insert and remove this reamer, the machine is stopped. And that's so that if I've got a chip on there or it's not centered and I'm inserting the reamer, that we don't get a spiral going down the chamber that we're gonna have to either polish out or scrap the barrel because of that. So very carefully finding center here, letting it guide itself until we make contact. So there we are, we've got our reamer stop. You can just see light through there, hardly at all. Lock this guy off, put her in gear, send it, and then we are just gonna go in a few thousandths. You can just see it start to bite. I've also got indication back here. I'm starting to feel some resistance there. So let's stop there. It moved quite a bit, but that's a lot of metal. I hope I didn't overshoot that just now. Maybe something wasn't tight, but fingers crossed. That is a lot of metal. Doesn't look like 8 thousandths to me. You guys might get to see your first barrel setback. That'd be fun, huh? So again, this has to be just absolutely clean. We will visually inspect as well. Still a little dirty. I don't like to use a lot of air, guys. If you use air, make sure you use very low pressure. You can atomize the oil in the air. You breathe it in, and I've had respiratory infections because of that. So don't go crazy with air and oil. Okay, we're looking good. Fingers crossed here. Make sure everything is clean. Okay, it closes with just felt like a kiss of resistance there. No movement fore and aft. That's good. We might have just nailed our headspace. I'm glad we didn't go any further on our reamer stop. Now, the absolute moment of truth. We've got our go gauge right here. If it closes on this bad boy, then we are doing a barrel setback. Make sure it's clean. Okay, doesn't even go halfway. Whew. Dodge that bullet, literally. All right, so we have achieved headspace. Next step, we got to pull this action. We are going to inspect our chamber, see if it needs a polish. I'll probably do a very light polish on it. This Reamer just left a beautiful chamber. No rings, it's incredibly smooth already. So we're not gonna need to do a whole lot there. But we'll do a slight polish, and then we're also gonna put a slight bevel on this and radius that a bit to help with feeding, and we'll go from there. Put a final little polish on the mouth of the chamber here so we get nice smooth feeding. It's a mirror finish basically. And this thing is ready to pull out of this chuck. We're going to lop the muzzle end of the barrel off, dial it in here just like we did the breech end, and we're gonna cut our threads and our crown. Moving along. Okay, the time has come. Time has come to mate this barrel to this action. We've gone in there and we've cleaned up the threads really well with acetone, gotten rid of all of our chips and grease and oil. Taken one last good look at our locking surfaces, make sure those are super clean. We've made sure the shoulder here is clean. Everything's clean and ready to go. What I'm gonna do here is I'm going to use a little bit of blue Loctite. Not so much for the thread locking purposes, but I like the first few threads to have kind of a seal, and that will keep things like copper solvent and cleaners out of those threads and keep them from corroding and eroding and things of that nature. And more importantly, I think, is stainless on stainless. We have something like anti-seize so that when we break this thing down again at some point to rebarrel it, we're not destroying both the barrel and the action. A lot of manufacturers don't take those precautions, and unfortunately I've pulled a lot of barrels and they've just come out ruining the action and the barrel because there's galling, and once that starts there's no way to stop it, and essentially it just rips the threads out as you go. So shame on them for not doing that, but we're going to take the precaution, and doing so I'm just going to add a little bit of blue Loctite in here first. If we put it on the barrel, then if we were to put it here, our blue Loctite and then our anti-seize, the blue Loctite would run all the way through the threads there and they would kind of counteract each other. So I put a little bit of Loctite in here, and we're going to put a little bit of anti-seize on the barrel itself. There we go. I don't want it quite that far up. Like I said, just the first 3 threads or so. Action wrench going in, torque wrench going on. It's torquer. There it is. Got our go gauge. Closes beautifully, no slop there. Should not fully close on this. This is our no-go gauge. Yes, did not close beautifully right at the top. Perfect tactical headspace. Guys, we are ready to start assembling this build. Wow, I'm excited to see this thing come together. Hope you guys are too. Well, let's do this. Let's throw this thing together. First things first, we need to hang this trigger. And I cannot wait to use these nifty threaded trigger pins. Man, what an evolution. Tell you what, Joel put his spin on this thing and I'm digging it. Anytime we're using threads or thread locker, we have to clean our threads. I won't say there's no point to using thread locker if you haven't cleaned your threads, but it works 10 times better if you do. If you've got grease or oil in there and it's allowed to slip on the surface of the thread locker, it doesn't do a whole much. Doesn't do a whole lot. So we're cleaning the threads. Now if you go on terminusactions.com, Joel has some tutorials on how to hang this trigger, and he recommends, of course, just a dab of blue Loctite, which I couldn't agree more. One drop. Man, this is so much nicer than pounding on this thing with a sledgehammer to try to get your pins in. All right, bottomed out. Don't need to be crazy tight. Wipe up our excess. Beautiful. Wow, that was easy. Let's keep moving along here and put this thing to rest in our MDT ACC chassis. I'm equally as excited about this. Anytime this is going in a chassis, and I kind of did a quick inspection before, but we want to make sure that the bedding surface here is absolutely pristine. Another surface is this recoil lug surface. That has to be pristine. Make sure there's no weird excess coating or any manufacturing blemishes there. And everything looks good. Also, we want to make sure that when we set this in here that our safety clears and that this chassis is built for this particular trigger and action. And of course it is. This is a great thing when you use high-end components, guys. Things just work. It's when you start going cheap on stuff and using things that you're not necessarily supposed to with other parts. This build is just coming together flawlessly because we're using high-end stuff. So this is the result we expect. Moving forward, we want to, again, make sure our threads are clean. Here's what we do when it comes to thread locker on an action. I don't like just putting the thread locker on the threads of the screws, because what will happen is when you thread them through the chassis and into the action, you'll get a ring of thread locker all around in between your chassis and the action. And I don't know that that hurts much, but I don't like it. I like having a perfect mate action to chassis surface. I don't like having anything in between. So I actually put the thread locker into the action. Be careful not to do this excessively because we don't want a bunch of thread locker hanging out on the inside of our action. And if you do, make sure that you clean it up. But we're just putting some just on the inside there, and that way it's going to end up where it needs to be and nowhere else. Next step, I always put the chassis on end here because we want this recoil lug surface to be making contact with the recoil lug surface of the chassis. So we're letting gravity do the work for us. We're going to insert our first screw here. And we're not torquing down just yet. It's literally just hanging in there. Rear action screw going in. And we want to make sure everything's aligned, nothing's binding, nothing's sticking out. Give this a firm handshake torque. All right. Now we need to bring it to spec. We've got our torque wrench here. It's zeroed. I'm going to go back and forth. This is 65 inch-pounds. For the love of God, not foot-pounds. Let's go to 45. 45. And let's bring it up to 65. There it is. There it is, ladies and gents. Made it up to our chassis. It's starting to look like a sexy looking rifle. Let's throw a bipod on there. Let's get the bolt in there, throw an optic on it. See what she looks like complete. Wow, guys, there she is in all her glory. Start to finish, you got to see it. Full build, 300 PRC, Terminus Action, MDT ACC Chassis. Wow, what a build. Super fun. Looks gorgeous. I hope it shoots as good as it looks. I'm sure that it will. Man, super excited. Of course, we got that Trigger Tech 2-stage trigger in there. Threw a little chunk of Picatinny up there and threw an Atlas bipod on it. As far as our optic, we're gonna run an Attacker 7 to 35, and we got Barbaro quick release mount, flatline ops, scope level. It's gonna be pretty sweet. I hope you guys stick around and watch the second video, and we'll get out and see what this thing can really do at some range. I'm gonna throw this a suppressor on there too to see what that looks like, but I can tell you right off the bat, man, the thing is balanced. It feeds great too. I have some factory Corner D 225 grain ELD match, and it feeds flawlessly. It really does. It feeds like my 308 at Slick. I was a little bit worried about it. I'm also running the MDT magazine as well. Man, guys, I'm super stoked. Thank you so much for sticking around to the end of this video. Again, please watch the second one if you want to see what this rifle can do.
All right, guys, that is it. The build is complete. There's only one thing left to do, and that is get out and go shoot this thing. Subscribe if you want to. Hit that little notification bell so you know when I post part 2 of this video. I'm stoked. I really want to see how this thing shoots. Also, go to griswoldgunsmithing.com, get your gear. We're going to be doing some long range shooting, so I'm going to need a spotter. Dakota, come. Oh, you want to go shoot? All right. She's raring to go. Let's load up and get out of here. We'll see you in a little bit.